you. Hello, everyone. Oh, sorry about that. Just I'm still learning how to use the streaming platform. Thank you for joining this session. We'll hang around a couple of 1-2 more minutes, and then we'll start. In the meantime, I left in chat the URLs for registering for the AWS giveaway, which contains 20 cloud practitioner uh, certifications. I mean, 20 vouchers for the AWS Cloud Practitioner certification and three $100 vouchers for the AWS Merch Shop. Thanks again to Ryan Nolet from the AWS Security Outreach team for helping us with such a big number of vouchers. It's really amazing. If you want to start cloud security and you don't really have a certification yet, then this might be the right chance to get one. You will have to complete the registration form, and the next days we will announce the winners. Just so you know, we have at the moment 30 submissions, meaning that you have to be unlucky to not win. So sorry for those that will not win, but chances are that there are high chances that you will win either of those. And I also left a feedback form, which will help us and also me for promoting future workshops, so that we can highlight your feedback, what you liked, and we can improve based on what you didn't like, or what suggestions you might have for futures workshops. Cool. I will start sharing now, and we will start with today's agenda. So, okay, I hope this works. Let me just check 1 second that I have a second laptop here. I want to make sure everything works. Obviously, I don't want it to be that small. This should be fine, I guess. No, maybe. Okay, this should be better. Cool. For today, we'll cover how to report and calculate CVSS score for cloud misconfigurations, which is not as straightforward as you might think. Next, we will. I'm sorry, I just want to remove additional logos and stuff like that so that we can you can see more of the screen. Great, and let me just remove my name. I wonder where was that? Well, in any case, so today we'll cover how to calculate CVSS score, how to communicate with clients, especially when sensitive matters, how to calculate the effort for an engagement, how to avoid common pitfalls that at least I encountered, and you can learn from my mistakes so that you will not repeat them, how to upsell your services when you are trying to do cloud assessments for companies. We will cover what resources you can use to improve your knowledge. How is the setup? At least I am using, but you can use as well. You can use that as well. And we will talk about certifications. And I highly encourage you to leave questions, to have an open discussion, because this will be a short session, and based on what questions you have afterwards, we will remain and talk and answer all of them. And I hope that sounds good to you. Good. So let's start with CVSS, and we will cover two examples for to understand why is this an issue. First of all, let's take a very common finding that in most engagements, you will find it in a way or another. And that finding is S3 bucket does not enforce HTTPS communication. And just to give you a better idea of how this would look like as an attack. So we have a bucket and we have someone, a user, right? And the user wants to access a file within this bucket. And by default, buckets support both HTTP and HTTPS communication. Well, let's assume that there is an attacker that will position themselves between the legitimate client and the S3 bucket. And the attacker performs some kind of HTTPS downgrade, TLS downgrade, so that the connection will be transferred from HTTP to HTTPS, no, from HTTPS to HTTP. And then the attacker will be able to check everything that's sent back from the bucket to the client. Well, obviously, this is very a very difficult attack to actually encounter. Even more, most of the buckets do not contain sensitive data. So you have to be careful even how you report this. If the S3 bucket just has some public website data, then it doesn't really matter that the bucket um, supports HTTP. Now, before we move to calculating the CVSS, I want to highlight something else. There are certain findings that you have to report because if you don't, someone else with a scanner, with just a simple scan from a tool, will highlight this issue. And this issue is in most compliance benchmarks. And because of that, the client will fail compliance, and then they will ask you, "Hey, why didn't you report this? Why is just that we're finding about it now?" So even if it's a lame finding, you still have to report it, and you still have to calculate a CVSS score for it. Now, from my point of view, what I would do, I would make a big category at the end of the report with hardening configurations that are mostly informational or low risk. And I will include findings like this one, the S3 bucket does not enforce HTTPS in that category because it's not really that big of an issue, but at the same time, you have to report it and you will actually teach the customer something in case they didn't know about it. And most clients actually implement this fix because it's very easy, doesn't break production, and it saves them from being uncompliant to some policies. Now, if we were to look at the attack vector, I would say that the attack vector would have to be adjacent. It would be hard to be over the network to perform a man-in-the-middle attack. Attack complexity obviously high. Privilege escalation required kind of it. I know it's not really, you don't really need to have privileges in AWS, but at the same time you are in a high privilege uh, position, being able to perform a man in the middle between the client and the AWS APIs. So I would say somewhere around high. User interaction, yes, you need that because without it, no request will be made. Scope unchanged. Scope will be unchanged, and confidentiality it depends on what's in the bucket, but most cases is low. Integrity can be low and availability low, but if you do it like that, you have 3.9. And I know it's not the best thing to do, but think about it like this. You will have other findings, and I can tell you from experience that most misconfigurations that you will identify, they will have under 4, a CVSS score under 4. And you kind of have to compare it a bit with how much more or less severe are other findings compared with the lowest ones. And 3.9 in cloud configuration reviews, it's actually not a lot, but there are more important things that are not as high. And you might want to put integrity and availability on none. Obviously, this is very dependent on your context and what is actually inside the bucket. More sensitive data might have a higher score, but the most important thing is you have to be able to argument why did you choose these values. In case the client doesn't really like or the client they disagree with your assessment, they will come back and they will ask you, hey, why did you put, let's say, the attack vector on network? If you don't have an answer for this, uh, they will start question other things too, and it doesn't really show well for you as a security engineer. So whatever values you select here, even if the CVSS is maybe higher, maybe lower, be prepared to be challenged by the client and be prepared to explain to take your ground and say exactly why did you put that value. I think that is the most important thing when you are calculating a CVSS score for a misconfiguration. Because as you noticed, it's not like you can actually perform this attack. It's just a misconfiguration that maybe it will be exploited at some point, but you are not actually exploiting it. Imagine a web penetration testing where you are reporting a SQL injection. Well, you kind of exploit it and you can show impact, you can show that is possible. And the CVSS is much more applicable to that type of vulnerability, right? But in cloud, it doesn't really work like that. You have to think about a real attacker doing exploiting that misconfiguration, but you are not really doing it. And because of that, most misconfigurations will have a low risk and they will be challenged by the customer if the risk is too high. And you want to be able um, to hold your ground and explain to them why did you choose these values and essentially why is the CVSS like this? Because of course the score is the one that matter. And when the client will come and ask you about it, they will try to check anything that can be modified so that the risk will be low. So that is one example on how to treat low severity findings. But let's say you have something else. Let's say you have a privilege escalation. So you have a Lambda function that has a really high permission role, or maybe not even high permission role, but this role has a privilege escalation vector in it, right? And now we have a YAM user. YAM stands for Identity and Access Management. I want the AWS icons. I don't think this is it, but I will choose this. Good. And you have here, this is a developer. And this developer, essentially, they have permission. So they have a policy. By the way, if you're not familiar with diagrams.net, previously known as drone.io, I highly recommend it. It's a really cool tool to make diagrams. Good policy. I don't find the one that I want, but I'll check this out. So essentially, this developer is an identity from the AWS account, and they can modify the code from this Lambda function. And because they can modify the code, it means that this developer will have access to whatever the Lambda function is able to do through this role. And because this role has a privilege escalation vector in it, the developer will be able to escalate privileges through the Lambda function code using the role attached to the Lambda function. That's actually very common. I mean, not very common, but I've seen it a lot. If it's not a Lambda function, is an EC2 instance, and so on and so forth. But you'll find privilege escalation vectors. Now, you are doing a cloud configuration review. You are not this developer. You are actually just a read-only role from this account, and you can only see that this exists. But you can do it, right? But you still have to calculate the CVSS. And now you have to come here because it's in the AWS account. If there are no network restrictions, then it's over the network. The attack complexity now, this is where it gets hard. So you might argue that you will need to compromise the developer account, and then you will need to edit the code of the Lambda function and perform the privilege escalation vector. You might be tempted to set it as high, but I would put it as low, because if you think about the prerequisite of compromising the developer account, you can argue that you cover that here, right? Because there are privileges required, so you are setting it here as low or high, and you are not including it in the context of attack complexity, and you set it to low. Again, if you want to set it high, that's totally fine. Maybe the user also has MFA and it's a bit more complex. But in any case, that's really up to you and your context. And just if, as long as you are able to say why did you choose that value, it should be fine in the end. You can open a discussion with the client, and everyone will be happy to discuss and change anything that wasn't properly set. User interaction is none. We don't need it. Scope unchanged. And now, well, theoretically, it would be confidentiality high, integrity high, and availability high. Why? Because if you compromise, I mean, if you escalate privileges to administrator, then you kind of fully compromise the whole AWS account. Now, if that role of the Lambda function didn't really have a privilege escalation vector, maybe you can say that this developer from their permissions, now they also have access to these permissions that are a bit over permissive, and maybe these values will be a bit low. Now, as you can see, if we leave it like this, it's 8.8. It's a bit high. I can tell you that most customers will think this is too high. At the same time, it's a privilege escalation vector. Like, you don't want to lower unnecessarily the severity of the finding, because if this finding will be exploited by a real attacker, and escalating privileges to administrator will fully compromise the AWS account, the customer might come back to you and they will ask you, hey, why did you only report this as medium? It was exploited, and look at the real impact of the fine. If we would have known that it was indeed a high risk finding, we would have fixed it back then. So you want to avoid that, right? In my opinion, it's better to set the severity a bit high, higher than what would the client want. But if that fits the reality, and in this case, it kind of fits. So if you want to just keep it a bit down, you can set the attack complexity to high. And then so let's do one more thing. Let's say that even if it's not really the case here, but you might have this discussion that the user has MFA, and in order to compromise it, you have to do a phishing attack. So you have the user interaction required. You can be like, okay, fine. So we went from 8.8 to 7.1, which is still high, but it's kind of in the lower limit. Like it's barely high, but it makes sense, you know. It's a bit more pertinent with the customer, and when if they ask you, I don't know, to change it, now you can really say to them that this was initially 8.8. We took a second look. Here is what we changed. Please tell us why should we change any of these values and how, and just wait for an answer. Like if they can't argue that anything from here should be changed, and if you don't agree with it, just don't change it. I mean, it's your reputation in the game. There is no point in lowering a vulnerability just for the sake of the customer. Keep it as it is, or let anyone that would assume changing this severity from high to medium change it, but don't do it yourself, because it's really not worth it. And when things will go bad, you will be the one responsible because you didn't report it as you initially wanted. So just leave it as it is. Good. That would be about CVSS calculator. As I said, I mean calculating CVSS. As I said, if you have a lot of low risk findings or informational findings that are not really creating problems, but it would be better to have them modified, then just make a section at the end of the report and write all those findings there with some short descriptions. And the client might appreciate that you are not making a big fuss about small components. And in some cases, you will not know all the details about the environment, so you will actually, some of the things you will report, they will be false positive for them, and it will make their life easier internally, because they will be able um, to argument that hey, look at this report, they even said that this is not a big issue, so you can ignore it, and here's the reason why. Good. Now there will be cases where you will have findings that they really should be fixed, and you have to convince the customer that they should be fixed. Like for example, let's say I have sorry, one second. So let's say we have a privilege escalation vector. So this role is assumable by any other AWS account. So we have this role, and we have a second role, a second attacker, a second AWS account. And let's say this account is controlled by us, right? And in this account, there is this role that is assumable by any other AWS account. meaning that if we know about this role, we will be able to, assume it from our own AWS account. But in order to assume it, we will need to know the AWS account ID and the name of the role. Well, if we go back to CVSS, there is not enough, you can set it high enough to reflect how big of an issue this is. Like network attack vector still remains network, attack complexity has to be high because you have to identify the name of the role, which in most cases you will not be able to do it. Privilege required, however, is none because you can do it from your own AWS account, which you can create freely. User interaction, none. And confidentiality, integrity, and availability will stay on high. Well, this is actually by all means a critical finding. And you have this CVSS that tells you that it's only 8.1. So now you have another problem. You have a vulnerability that is actually critical, but you have to explain to the client how important is this. And just because it's high doesn't mean that it should be treated as a high. You can set the attack complexity to low, but it's not low, right? I mean, you have to brute force that username. You have to find it, that role name. You have to find it from somewhere else, and that's just not something that you can do easily. So you have to keep it on high. Well, what you can do is one, report the finding as it is with the CVSS score, and in the description mention that this is a high finding according to CVSS. However, this is a critical vulnerability in terms of the impact and what can go wrong. And ask for a meeting with your customer. Ask for a meeting with whoever is responsible about the cloud account, but make sure that is someone who understands a bit of cloud and do a proof of concept. Like show them, hey, look, I wanted to make this meeting to show you how bad is your configuration. And look, from my account, I can assume this role from your account. It has right permissions. I can fully compromise your environment just by knowing that this role exists. If they still don't believe this is critical, at least you did everything you could, but you have to go a big extra mile to make sure that they understand when something is really serious and that problem is not reflected by the CVSS. So CVSS kind of doesn't really fit with cloud misconfigurations. On one hand, most of the findings, I mean, the issue is that most of the findings will be lower in severity and they will be treated more lightly by the customer. Some of the findings are hard to be put in the context and metrics of CVSS. And findings like this one, which is in fact critical, is not really reflected on the CVSS score as so. So you have to adapt and you have to choose the best solution that keeps you safe in case anything goes wrong after you deliver the report, but also makes the customer safe by explaining them as good as possible what is the actual risk of the misconfigurations. One trick that you can use is to try to talk with the person that is responsible for security, because you can go to them and say that this is really serious. If this gets exploited, it will be really bad for your environment. And because the security person is responsible for ensuring the security of the environment, most often than not, they will actually push their team to fix it because nobody wants to be responsible for the breach of their employer, right? That's not something that people want. There are cases where people genuinely care about the security of their company. But there is another layer of you don't want to be that person that clicked on the phishing link, that granted access, that allowed a vulnerability in your environment to exist, and not fix it. So going after these employees that are responsible for ensuring a good security in the environment will increase your chances of getting the issue fixed. Obviously, this is all extra mile. You don't really need to do it, but if you really feel like this has to be fixed, and you want to push a bit more for the issue to be fixed, you can go this route. But again, be careful. This is an industry, money are involved. You don't want to lose clients left and right just because you care about security. So find your middle ground. I had the bad luck of, in quotes, bad luck of reporting too many findings for a customer, and they actually decided to stop collaborating with the company I was doing services for. So there are cases like this, but at the same time, if you want to do security right and sleep better at night, just do your thing, and other clients will come along. Good. I'll check the chat to see if we have any questions. So far, we don't. We'll move to the next topic. Whenever you have questions, just feel free to leave them in the chat. Now, I want to talk about calculating the effort for the engagement. And here, I want to share one story from my first engagement. So I just started doing AWS security reviews, and I did my first 2 or 3 reviews, and a new project came along, and they wanted the same thing. They wanted an AWS security configuration review, and we said yes. And I let them know what I needed to perform the review. But I haven't asked how many AWS accounts do they have. So it was a 2-week project, so 10 working days, and they had 27 accounts. 27 accounts. It's just a lot. Even now, with all the experience, like I can't do. I don't know what is happening here. I can't do 27 accounts in 2 weeks. I can run enumeration on them, but I'm not sure I will have the time to go through all the findings. The best I can do is a best effort of filtering critical and high severity findings. But in any case, I didn't ask how many AWS accounts do they have for the review. So I just received 27 AWS accounts with credentials, and I did the best effort. It was kind of a mistake from whoever was in charge for doing the estimation, but also from my end because I didn't raise this issue, and you don't want to be in this position. Better, I mean, anytime, just ask the client how many AWS accounts are and how big the accounts are. There are companies that follow best practices and they actually deploy, if they have a new web application, they deploy it in a separate AWS account because that's a good practice. And having additional AWS accounts doesn't cost you more money by default. So it's good. It's a good thing to have multiple AWS accounts. You just have to review them um, constantly when you create a new one and not wait for gathering a batch of 100 AWS accounts and expect someone to actually review them in a good amount of time. Now, there is another scenario. You have an AWS account that your customer is saying, "Hey, we have only one AWS account," but you don't ask how big it is, for what is it used. And I reviewed some accounts that were really big, and they had resources that couldn't be covered with tools. They had to be reviewed manually. They had over 1,000 roles. I think it was like 2,000 roles or something like that. Tens of users, groups, a lot of resources. They had in the same account multiple environments, staging, production, and so on. And well, one, you can cover everything from that AWS account if the time is short. Like if you just say, I will cover this account in a week. That's just not doable. You will do a best effort, but that's pretty much it. And you have to ask the client what are they using this account for. And if they are saying something like this is our only account and we deploy everything here, ask them exactly how many solutions, how many web applications, how many users do they have here. The most time-consuming resources to be evaluated are the identity and access management solutions, because you have to, at least I pretty much doing manual analysis over the privilege escalation part, because this way I make sure I don't miss anything out. And for that big account, I actually try to run Principal Mapper, a tool for showing privilege escalation vectors, and the tool crashed because there were too many resources. What I ended up doing, I was actually reported this issue as being a finding. The account was too big to be properly reviewed, and that in itself is a issue that was a finding, and I think I reported it as high because it is indeed a big security issue. Not, and imagine if that account gets compromised, how bad that would be. So you need to know two things: how many AWS accounts are there, and how big are these accounts to begin with. And based on that, you will you will be able to give an estimation. Um, I wouldn't go with less than 5 working days, especially in the beginning, especially when you're not sure what you will encounter. If you can push for 10 days, even if you invoice for less a number less of days, it's still fine for learning something new and getting more familiar with your methodology, your working pace, and so on. In the future, you should be able to do more or less any type of AWS account in 5 working days, and things should go fine from that point forward. Another another pitfall that you might encounter is be careful at what your client expects from you to review. So you have, let's say they want you to review an AWS account, and this AWS account, they have some EC2s, um, S3 buckets. They have an cluster Kubernetes and some other resources, let's say also. a Lambda function. So, normal resources, no problem with this so far. But it matters what are the expectations from you. Does the client expect you to connect to the EC2 instances and actually review the configuration from the operating system? Because that's not something that normally you would do in a cloud configuration review. Does the client expect you to check every file from the S3 bucket for secrets? You might be able to do that with tools like Truffle, but it's not something that it is normally covered in cloud configuration reviews. Regarding Lambda functions, does your customer expect you to review the code from each function? Again, not really possible or not really in scope. I personally like to check at a high level the code from the Lambda functions, but I'm not like saying to the customer beforehand, hey, just so you know, I will cover the code from every Lambda function, because some Lambda functions are written in code that is not that easy to access. For example, for Java, you have to download the code from the function. You can view it from the web console. It's not that it's not just as simple as reading a small Lambda function written in Python. And then it comes the issue with AKS, Elastic Kubernetes Service. So this is actually a separate engagement. You can check the settings from the web console on the cluster, but other than that, you can't really, at least you shouldn't have to connect to the cluster and perform essentially a Kubernetes configuration review. That's a separate engagement. That's a separate skill set. It is related to cloud security, but it's not the same thing as doing a cloud security configuration review. So I had projects where I had to do a AWS cloud configuration review and Kubernetes security configuration review. And usually it's like 5 days AWS account, 5 days Kubernetes cluster. It's a separate engagement. Make sure the client doesn't expect you to just connect to, and also it requires uh, some additional setup for you to being able to access the cluster. So make sure the client understands that just because they have a Kubernetes cluster in the AWS account doesn't mean you will cover it from inside of it. You can check some basic configurations from outside the cluster, but other than that, I wouldn't go saying that yes, we will cover the Kubernetes cluster as well, because it's really a separate project, and it is a different skill set. Okay, that brings me to the point of what other related resources are complementary to the cloud environment. So if you think about it, uh, you can say that cloud security starts with the developer that is writing code. Because if that code is insecure, it will be a breach in the end in the hosting platform, which is the AWS account. At the same time, if the repository is misconfigured, meaning that you have a branch where a developer can self-merge a pull request, so they make some modifications to the code, they create a pull request and they self-approve it. That's also an issue, because doing that, it might trigger a deployment branch or a CI/CD. I mean, they will trigger a CI/CD pipeline that will deploy the malicious code, and it will reach the AWS account, and it will compromise the environment. The same goes if you have a CI/CD pipeline misconfigured with vulnerabilities and so on. So you can argue that cloud security, it's not just at the level of the AWS account. It's more than that. It's like it's a process. It's something that is interconnected, connected with other components. Make sure the customer understands that what you're providing is just the configuration review from the AWS account and nothing more. If they want any of the other things, they can be separate engagements. So you can do CI/CD pipeline configuration review, configuration reviews of the GitHub, GitLab servers, how the repositories are configured, and so on. Secure source code uh, review. All of them are possible things, but they are separate engagements. So make sure you are not signing more than you can actually give, and make sure you set the expectations right with your client. But all these options, they are points of doing upsell in the future. If you, I mean, not in the future, but whenever you have the chance, if the client comes to you and says, "Hey, I have an AWS account, I want you to review it," and they say, "We also have an Kubernetes cluster in here," you can ask, "Hey, don't you want us to take a look inside the cluster as well?" Most often than not, they will be like, "Yeah, sure, do that," because it's worth it, right? If this gets compromised, you will get initial foothold in the AWS account, so you want to make sure this is secured. Also, that goes with the other services as well. So you can use this interconnectivity of services, of technologies, to uh, to sell more services. Let me check the chat. We have some spam, so we'll ignore it. Good. We'll move forward. Now we'll talk about learning resources and then certifications, and we will shortly reach the end. So if you have questions in the meantime, you can just drop them in the chat. Good. Let's talk about labs. So if you want to learn more about cloud security, there is this repository, Awesome CloudSec Labs. And here you have a list of a lot of labs that you can deploy in your AWS account, or you can register accounts to use them. And there are some of them that are 24/7 online for you to try to hack. So, for example, last session, I gave access in an AWS account that had some uh, adjusted versions of the what is it? YAM vulnerable done by SetArt and SetCloud done by NCC Group. So the environment was based on these two labs that were deployed with Terraform in my own AWS account. But as you can see, you have other labs here as well, and the cool thing is that you can deploy them and then you can just run Terraform destroy to bring them down. Obviously, make sure that you are not leaving them exposed and you are not leaving them running because it will cost you money. And we will talk shortly how you can handle that better. Just know there are some platforms like Pwn Labs and Cyber and Hack the Box and Try Hack Me that have hands-on labs on cloud hacking, but I never tried them, so I can't really recommend them. But people are saying good things about them. Some things that are 24/7 online: the Big YAM challenge from Wiz, flows.cloud, and flows to that cloud done by Scott Piper, which are uh, always online, and you can try. They have some misconfigurations. You can try to exploit them. They're really fun, and you have hints. You can get the answer as well, the solution. But you can just try to complete them yourself. Uh, really cool challenges. Now, when you deploy this infrastructure in your own AWS account, you will be vulnerable in most cases for a short period of time. How you can make sure no one hacks your account, at least how you can decrease the chances. So there is this service AWS organization. Um, right. So this service AWS organizations can allow you to manage multiple accounts, AWS accounts at once. Um, and essentially, in this account, this will become a management account, and you will be able to create additional accounts. And what setup I usually use, so I create at least 2 additional accounts. That are under this account. And when I have to make a quick test that will not expose me that much, I prefer to use, let's say, account A. So this is for small tests, maybe not really vulnerable components, but I just do some small tests, some small quick tests here. The other one is for vulnerable components, meaning that in this account, I will deploy vulnerable resources that might get the account hacked. When I'm doing workshops or live demos, or like we've done, I gave you access inside an AWS account of mine. I use such an account that after the workshop ended, I just deleted it. So not only I removed all the components from the account because I was able to use Terraform destroy. I also deleted the AWS account just to make sure that no other resources left here or maybe created by whoever compromised the AWS account were still left there. And as soon as I delete this account, I create a new one. So there is no limit on how many accounts you can create and close. I mean, there is no small limit on how many accounts you can open and close, and you can do this kind of for free. It doesn't cost you anything. The only thing that costs is the resources from your account that incur costs. Even if using AWS organizations doesn't cost you anything. Now you will notice that I didn't say what I'm doing in this account, the management account. And the reason is I'm not doing anything here. So this is actually management account, and I'm using it only for managing the other accounts. I'm doing this because this is actually good practice, and I just don't want to create a new organization. That's mostly it. Now, how you can make sure when you deploy a vulnerable infrastructure, a vulnerable lab, how you can make sure you will not get hacked, or at least you can try to make things safer for you. You can set a service control policy in the management account. A service control policy is a policy that you can apply to multiple or a single AWS account from the AWS organization. And what I like to do, I like to set, okay, I like to set a service control policy saying that API calls made, I guess this is not right here, but API calls made to this AWS account that has vulnerable components will be allowed only if they come from my IP address. And I type my IP address, and basically whoever doesn't have the same IP as me, it will not be able to. They will not be able to perform API calls to the resources from that environment. So it looks something like this. So this is me, and this is attacker with whatever IP they have. And essentially, when we make this request, they are evaluated. It's not really the best diagram because it's not like a real firewall, but it's something like both requests are evaluated based on the policy. This looks bad. Okay. So both of them, both requests are evaluated based on the resource policy on the management account, and whoever doesn't fit the policy, so in this case the attacker, because they will have a different IP than mine, they will get a deny. They will get denied from performing the API call, even if they have. That just looks bad. Even if they have the permission to perform that action, they will not be able to do it because they don't have the same IP address. And this way, I make sure, at least to some extent, that I'm the only one that can communicate with this vulnerable AWS account. Just make sure that you set it only on the vulnerable account. This might break some things, and if your internet service provider changes your IP from time to time, then setting this policy also on the management account might prevent you from accessing it and modifying the service control policy. I guess you will have to connect with the root account, but just make sure you set that policy only on the vulnerable account and not on your whole organization. And that's pretty much why I'm working when I have to test things out. I deploy the vulnerable component. I set the service control policy to make sure nobody else will exploit this account, or at least I try to prevent it. When I'm done with tests, just to sleep okay at night, I delete the account and I create another one. And I keep a second account for doing some small tests with resources that are not necessarily exposed or hackable, just to make my life easier. So that would be pretty much it. You have some options to manage access in all accounts with YAM Action Center, previously known as YAM Single Sign-On. Anyway, and with that service, essentially, you create a single sign-on page that you can use to connect centrally to any of these accounts. But that's the recommended way to do it. But it's a bit advanced in the beginning. Just start with this and join the Cloud Security Slack forum, because there you will find help in making a safe configuration if you encounter any issues. Obviously, you can also write me about it, but maybe getting more opinions on it is a better thing. Let's see, we have a question. Um, Somebody asked what is the topic today. Today we cover tips and learning resources, and welcome to the stream. Let's talk about certifications now. So the best certification you can get is the AWS Certified Security Specialty. Is the best one because customers understand it. So if you come to them and you tell them, "Hey, I have this certification from I don't know, offensive security from SANS," they might not understand what you're saying. But if you're telling a company that is working with the cloud that you have a security certification from the cloud they're using, they kind of there is no need to understand more about it. It's just they trust you to some extent, and that's why I think this certification is the most important one you can get if you want to get more projects. Just keep in mind that if you are coming from an offensive background, you will have a harder time taking it. It's actually dedicated for cloud engineers that also implement security. And you'll see somewhere around here, they have some recommended prerequisites, and they have like 2 or 5 years of experience with AWS. And I understand why. You can take it without that experience, but just know it's a bit hard. I personally did a course on Udemy, especially for this certification. It really helped me. It really put things in the context of real life examples. But after I finished, I mean, now thinking about it, a lot of the stuff I learned back then, I forgot because I'm not using them. I don't need them on my day to day workday, but I have the certification now and I can tell to customer that I know AWS security. I have other certifications as well when it comes to cloud security. I have one for cyber warfare from Cyber Warfare Labs. It's called Hybrid Multi-Cloud Red Team Specialist or something like that, which was a really cool practical exam for this certification. You have to compromise, so you get initial access in GCP, and you have to compromise GCP, compromise AWS, Azure, and then compromise on premises infrastructure. Very cool, but nobody really knows what cyber warfare is. But if you want to learn something new, that's a good certification that you can take. I also have a certification from SANS for the cloud penetration tester something, which I only took the exam. But again, these certifications don't really talk to customers as it talks this AWS certified security specialty, which is unfortunate if you have an offensive background, but it's if you look at the price, it is a lot cheaper than an offensive certification. And you are learning more about the platform you're about to review, and maybe some researching idea will come out. Maybe will I mean, overall, the knowledge and experience from this certification will help you. It's not that easy if you don't have cloud engineering experience. And that would be all regarding certifications. I know that now on the internet there are platforms that they have exams and they have certifications. I think they are cool, but if you go with them to a customer for doing configuration reviews, I'm not sure they will matter that much. But that's just my personal take from personal experience. Um, take it with a bit of caution. Good. And this covers it all. That was all I had in mind to cover today. Um, we will stay a few more minutes to take some questions in case there are any questions. Mm, In the meantime, I left a feedback form. It would help us and me greatly if you leave us some feedback. We will be able to make our content better, and also we can use your reviews for promoting this workshop or maybe other workshops on in the future. The recordings of all the 5 sessions will be in a playlist on YouTube on the DevCon Cluj channel, and the recordings will also be on LinkedIn. But I think it's just a lot easier with the YouTube channel. Personally, I want to thank you for coming to these sessions. It was great not talking all by myself, and it was a good experience for me and DevCon Cluj to provide this first online shopping. Um, don't forget about the registration form for the AWS giveaway. In the next couple of days, we will announce the winners. And I think this was it pretty much. So to make a recap, in the first session, we covered what it means cloud security and how it compares with cloud hacking. In the second session, we covered with Ryan Nolet, from AWS Security Outreach Team, the do's and don'ts when it comes to perform security engagements in AWS. In the third session, we cover how to do your first cloud configuration review, focusing on a manual approach. The fourth session, it was with Tony, the CEO and creator from Prowler, and we covered how you can use Prowler and automated tools for improving your configuration review process. And this session was about tips and tricks from AWS engagements, from especially from my personal experience. Um, and what else? I think this is it. On 10th of April, I will be presenting at AWS Community Day here in Romania in Timișoara. I will have a shared talk with Tony from Prowler. We will present a live demo on how to attack and defend the cloud environment using some predefined attack vectors, which will be really cool to share the stage with him. And for anything, you can find me on LinkedIn. My name is Eduard Agapibloaia. Or on Twitter at Sawyer Pocket. Make sure to follow the DevCon Cluj communication channels, as other workshops will be published, not on cloud security, most likely, but on other topics. But maybe you don't want to miss them. So no more questions. We'll end the stream here. Thank you again for participating, and any feedback regarding the workshop is